In this video, we'll show you how to configure your ARC 200 motor driver for use on an electric scooter or any other simple electric vehicle that has a single brushless motor. We love our scooters here at FreeFly, so much so that we've acquired quite a few of them over the years. All of these started their lives with weak brushed motors, noisy chain drives, and repulsive lead-acid batteries. We replaced all that crap with high-powered brushless motors, quiet belt drives, and exceptional LiPo batteries to create what falls nowhere short of a true super scooter. Before we get into the ARC setup, we'll take a closer look at each of these scooters. This is a modified Razor E300. It has an Alien Power Systems 80mm Outrunner motor rated at 8 kilowatts. There's a 10 amp hour 12-cell LiPo battery under the deck with an integrated battery management system for easy charging. It uses an HTD5M belt, which creates a smooth and quiet ride. The front pulley is machined aluminum and the rear is 3D printed out of ABS. It has a twist grip throttle and a separate thumb throttle for controlling regenerative braking. It has a top speed of 50 miles per hour with a 15-mile range. This is an older model electric scooter that has since been discontinued, but if you're lucky enough to find one, it makes for a great brushless conversion. It uses a modified Honda Civic power steering motor, an HTD5M drive belt, and a 12-cell LiPo on the back. It has two thumb throttles, one for acceleration and one for regen. One of the cool things about these scooters is that they have shocks for a smoother ride, and they fold up for easy transport. The top speed is 35 miles per hour, and the amount of style points acquired during operation is off the charts. Now that we've got you frothing over electric scooters, let's get into the ARC 200 setup. For demonstration, we'll run through the setup process on this scooter. It uses a sensorless brushless motor. When you're choosing a motor for your own scooter, you'll need to choose between sensored and sensorless. The main difference between the two is that sensored motors start spinning more smoothly. Here's a side-by-side comparison. For vehicles like scooters, where you can easily push to start, sensored motors are really not entirely necessary, but we'll show you how to set them up anyways. The first step in the setup process will be to solder an ARC flying lead onto the motor's sensor wires. If you're using a sensorless motor, you can skip this step. Motor sensor wiring diagrams can be found on the spec sheet of your motor. Here's the input diagram for the ARC. Solder the corresponding wires together from the flying lead to the motor. Red to red, black to black, A to A, B to B, and C to C. The motor's sensor wires can then easily be attached to the encoder plug on the ARC. Next, we'll wire up the throttle. For this scooter, we're using two standard thumb throttles, one for accelerating and the other for regenerative braking. These throttles are cheap and readily available online. To communicate with the motor drive, they output an analog DC signal. Most of these throttles have three wires: positive, negative, and signal. We'll start by soldering an ARC flying lead onto the throttles. For dual throttle setups, connect the acceleration throttle to the peachy orange colored wire and the regen throttle to the yellow wire. You'll also need to split red and black to each throttle. If you're only using one throttle, simply solder the signal wire from the throttle onto the peachy orange colored wire on the flying lead cable. Note that you can still have regenerative braking without using a second throttle. In this case, the first portion of the range controls the regen, while the majority is for acceleration. The flying lead then connects to the throttle plug on the ARC. The power wiring is very simple. You can plug your battery directly into the ARC 200 via the included XT90 connector. If you'd rather not have to plug and unplug your battery each time you want to turn your scooter on and off, consider wiring a switch in series with the power wires. It's a good idea to install a fuse in series with the power wires, just in case something goes wrong. Just select a fuse that is rated for slightly more current than whatever your max battery draw will be set to. Once this is complete, we'll move on to mounting the ARC in the scooter. For proper cooling, you should either mount your ARC to a metal component on the scooter or exposed to airflow external of the scooter. Note that the bottom side of the ARC gets the hottest, so it should be mounted to the metal or in the airflow. Now that all the hardware is set up, we'll start the ARC configuration. First, you'll need to install the ARC configuration application. It can be found through the link in the description. The ARC can be configured via Bluetooth or via the included USB cable. In order to configure via USB, you need to install an STM32 virtual COM port driver that can be found on the ARC wiki page. Choose the corresponding COM port or Bluetooth address from the drop-down menu, and then click Connect. Keep in mind that the ARC needs to be powered from the battery in order to connect. Next, we'll tune the ARC to match your motor. Note that you should disconnect your drive belts or chain from the motor at this point. First, navigate to the Configuration tab. This is where you can access all the ARC settings. Click the Setup Wizard button. This opens the general drive setup page that walks you through the steps to configure the ARC. We'll start in the Auto-Tune tab. It will help you measure important parameters about your motor, like resistance, inductance, and kV. First, click the Load Presets button and apply the Speed Mode Pre-FOC Tune preset. Then, close the window and click Send. Next, click the Measure Pole Pairs button. Mark your motor so that you can visually see when one full rotation has been completed. Click the Start Pole Pairs Measurement button, and then click the +1 button, however many times it takes for the motor to make one full revolution. Once this is complete, click the Save Results and Close button. The next few steps should be pretty self-explanatory if you read the instructions next to each step. Once you get to step 9, click the Slowest with Proportional Compensation option, and then click Run. This will calculate the optimal settings for your motor. Next, click Save and Close, and then Send. Next, click the Auto-Tune FOC button to open the Auto-Tune FOC window. Make sure your ARC is in speed mode, and the input throttle mode is set to QX. If you followed the previous steps, it should be ready to go. Note that we'll need to spin up your motor for this step, so make sure that it's securely mounted and in a safe location. Increase the RPM control slider until the magnitude number is in the green, and then click Start. After the test finishes, you can stop your motor and then click Save Results and Close. For step 14, set the Auto-Tune setting to Slowest with Proportional Control, and then click Run, and then click Save and Close. Complete the instructions on step 15, and then click Send on step 16. Also click Write to Flash in the Configurations tab. Now, we'll move on to the Sensors Sensorless tab of the General Drive Setup window. If your motor is sensorless, you can simply select Sensorless and move on. If your motor is sensored, select your sensor type. Most motor sensors are the 3-Hall sensor type. Then click Launch Encoder Cal. First, select your sensor type, and then click the Change Settings button. This puts the ARC into QX control mode, so that the motor can be controlled from the slider below. Now, slowly increase the speed of your motor until it is between 500 and 1000 RPM. Once the speed is consistent, click Auto Calibration. If the calibration fails, adjust the speed and try again. After the calibration is successful, you can stop the motor with the slider, and then click Save Results and Close. Next, go to the Command tab, then set the control mode. For most scooters, you'll want torque forward only. Set the input throttle mode to analog throttle if you have a single throttle, or if you're using a second throttle for regen, set it to independent analog throttle and brake. Then, launch the input throttle wizard. For step 1, make sure the input throttle type is still set correctly. Then click the Change Settings button to set the drive in safety mode, so that it does not spin the motor, and then click Send on step 3. If your throttle is wired properly, the throttle input number should change as you move the throttle. If you're using an analog independent throttle and brake, go to minimum throttle and click Set. Go to maximum throttle and click Set. Go to minimum brake and click Set. Go to maximum brake and click Set. If you're using a single analog throttle, go to minimum throttle and press Set. Go to maximum throttle and press Set. Then, for the input throttle 0 neutral setting, we'll need to determine the amount of throttle for the neutral point in between regenerative braking and acceleration. For most cases, about 1/3 throttle will work well. Go to about 1/3 throttle and click Set. Then click Set to ±5% to calculate a deadband. You can reduce this deadband later if your throttle feels like it has too much slop. After this, set the control mode back to torque forward only and click Save and Close. You usually don't want much, if any, throttle expo for scooters, but if you have an insanely powerful scooter and the throttle is really touchy, you can add some expo to smooth out your starts. Now, we'll move to the Startup tab. If you're using sensored motors, you can skip this step. For sensorless motors, set the torque mode startup to jitter start. The rest of the settings can be left at their defaults, or tuned later. In the Voltage Limits tab, select the number of cells your battery has. You can also adjust the individual voltage thresholds manually. The undervoltage cutoff prevents your battery from over-discharging, and the overvoltage cutoff prevents your battery from overcharging when using regenerative braking. Next, go to the Current Limits tab. Set the max battery draw to the maximum amount of amps that your battery can safely provide. This can be calculated by multiplying the capacity in amp hours by the C rating. Max battery regen and max phase regen controls how powerful your regenerative braking is. A good starting place is 30 amps. Max phase accel current can be set to the maximum number of amps your motor is rated to handle. This can be found on your motor's spec sheet. Be careful because high current draw can make the scooter accelerate very quickly. The Current Limits tab can be thought of like this. Max phase accel current controls the max torque, and max battery draw controls the max power. Now, we'll move on to the Drive Temperature tab. It can be set to prevent the arc from overheating. The default values should be sufficient, but if you'd like, you can decrease the temp foldback start to reduce power when your arc starts to get really hot. In the Speed Foldback Limits tab, you can configure maximum RPM, but this can be left untouched for electric scooter setups, unless you want to put a cap on the max speed. Once you're done with the general setup helper, click Save and Close, and then click Send and Write to Flash in the Configuration tab. If your throttle doesn't spin the motor at this point, make sure your control mode is set to torque forward only. At this point, you can put your drive belts and wheels on and test it out. It's a good idea to keep the rear wheel popped up off the ground at first so that your scooter cannot drive away. If the motor seems to behave as it should, give it a test ride. All the settings configured by the Setup Wizard and the General Setup Helper can be quickly adjusted as needed in the Configurations tab. Just remember to click Send and Write to Flash to save changes. If your motor happens to spin backwards, change the reverse direction parameter in the Configuration tab. Here are some parameters you may want to play with to dial in your scooter. If your scooter accelerates too quickly for your liking, reduce the max phase accel current. If your regenerative braking is too strong, reduce the max phase regen current. If your regenerative braking is too weak, increase the max phase regen current and max battery regen. If your motors seem to twitch or spin at zero throttle, try increasing the input throttle deadband parameter, or recalibrating your throttle. Note that sensored motors may make a faint gurgling noise at zero throttle. This is normal and just caused by noise in the current sensor. One of the cool features of the ARC is that it logs all sorts of data from your rides. To view the data, go to the Log Download tab, and select the log you'd like to view. Download the log, and then save it to your computer. The logs are saved as CSV files. You can open the CSV file in Excel or any other spreadsheet program to visualize different metrics over the course of your ride. At this point, your electric scooter should be working well. If you have any questions about settings we didn't cover in this video, check the ARC wiki page. The link can be found in the description. Happy riding, and thanks for purchasing an ARC 200.